Thank you for having me. It's good to be back on campus. Semiconductor is a hot topic nowadays, and one of the things that I've been saying quite a bit today and over the time, right, is that packaging is also an important part of semiconductor. We just heard this, right? So as I go through my presentation today, I have a lot of materials that I want to share with you. But I also have three things that I want you to keep in mind as I go through this, right? Takeaways, if you would. One is kind of what was my journey? Not so much about me, but about you connecting to your potential, right? You connecting to what could be, especially because, right, I didn't have this kind of session when I was going to Purdue. And I think it's great that you guys are here, and I think it's great that Purdue allows this opportunity. So I'm very happy to be able to share this with you. The second item that I want you to keep in mind is, I'm here to talk, of course, about Amkor, who we are, our space in the industry, our space in the supply chain, and a little bit of what the work that we do. But the third thing that I want you to keep in mind is that this is now not a be-all, end-all type of presentation, right? There's going to be more things that you want to be looking for, right? So that's the third thing. Explore your curiosity. Allow yourself to ask more questions, digging into the world of packaging and semiconductors in general. So, so again, Juan Gonzalez. I'm currently a senior director in the Business Solutions Group. We are a support organization to the business unit. So we provide cost modeling, pricing recommendation, process improvement, and ultimately, right, trying to get to that revenue optimization component, right? I manage a team of 4 great engineers. We're part of a bigger group of 10 engineers, and we report to the business unit. I've been with Amkor 15 years, and you're going to see in a little bit kind of what my journey was. Both of my degrees are from here, from Purdue, both in industrial engineering. Purdue runs deep in my family. So just as a personal background, so my brother started this journey. He's a chemie. My wife came to Purdue. My sister came to Purdue, and just recently in May, my niece graduated from Purdue. Just this fall, my nephew started at Purdue. So the Purdue connection for us is pretty big. When I'm not in the office, you can find me outside whenever the weather is double digits, right? Not so much in the summer. From a career perspective, started after my bachelor's, I started at Intel. I worked in a planning group. And at the time, I wanted to be more of a traditional engineer. So planning, while great, was not necessarily technical enough to what I wanted to do. I came back and finished my master's, went back to Intel, worked at the fab, worked at a lot of different functions there. At the time, I thought that I wanted to explore different industries. So I went into aerospace, found out that it moved a little slower than what I was used to. I found Amkor to be a good spot, but that also led me to, okay, what else is out there? So I allowed myself to explore. And again, I didn't want to necessarily go into the same type of industry to do the same thing. I wanted to do something different. Went into healthcare, and it was great. But again, the pace, the dynamics, it was not necessarily what I was looking for. Came back to Amkor, and it's been now 9 years since I came back. That's where the line ends for me. I don't see myself going outside of Amkor, especially not only because of the work that is going on, but also because of the opportunities within the industry. So this is a quick agenda. I'm not gonna spend more time there, so why don't we go ahead and dive right in. So I forgot, actually, let me go back here. So quick show of hands, how many have heard about Amkor before this session was scheduled? Wow, I'm actually impressed. That's really good. So outside of the folks that raised their hands, how many have heard about outsource model and semiconductor packaging? Very good. Very good. So this is what we're going to talk about. So Amkor actually pioneered the outsource model back in 1968. There's a little bit of history of the company and the folks that helped us there, right? The idea came from Korea, and it developed into this model that we have here today. Started with one package, 3 wire bonders and a couple die bonders, and now we have a broad product portfolio, and we service pretty much every customer, right? So IDM, integrated device manufacturers, that would be a company like Intel, for example, right? So we service our outsource needs, and also fabless companies, right? Those are the companies that can do or doesn't do the wafer manufacturing. They do the design. Somebody else is doing the wafer fabrication. We'll do the packaging service for them. And then ultimately the foundry. So this will be companies like TSMC. They'll do the wafer, we'll do wafer processing and onto packaging. Quick view of who we are. No need to memorize the slides, right? But a couple things. One, we're engaged with industry leaders from a customer perspective. 2, best-in-class R&D. And 3, from an automotive representation, we're the #1 OSAT in the industry. When you look at where we are, we have a small presence in the US currently, with our headquarters being in Arizona, but 12 million square feet all across Asia and in Europe. We pride ourselves into having quality be across the organization, not just at the factory, right? So yes, it starts with continuous improvement for the process, but also the business processes, right? The 0 defect in the factory, 0 defects as we go through our work. And ultimately, right, it starts with the employees, right? So building that base and helping us drive quality across the organization. Our strategic focus areas are here on the screen, right? Very pointed. Technology up front, right? It has to start with that. How do we drive, right? If we keep doing more of the same, we're not necessarily pushing the envelope and moving ourselves forward, right? So we pride ourselves in being a technology leader, being able to provide advanced packaging while also supporting the mainstream packages as well. As you saw, right, we have the broadest footprint across the industry. We just recently opened another location in Vietnam back in October of last year. And we also recently announced our plans to build a facility in Arizona that is upcoming. From a market perspective, we service all markets, right? And I'll touch a little bit more on that a little bit later, but communications, automotive, high performance computing, and AI. From an R&D perspective, because I know this is one of the areas that Purdue is working on, right? We have R&D engineers essentially dedicated in all the countries that we have facilities in, right? And we have toolbox that we work on, kind of internally and also with our customers. And we're learning, right? The stronger the partnership, the better the product is at the end of the day, right? And then, of course, right, this came up also earlier. We have to be a good citizens to the world, right? So we have our ESG commitment and making sure that we are driving that sustainable process, right? Making sure that we're doing right by the environment as we're doing right to our customers too. If I were to kind of summarize our priorities, right? Customer satisfaction has to come first, right? But that doesn't happen without a company culture, right? We have to have that company culture that enable us to focus on the customer, to drive good service, drive good quality, and ultimately push the envelopes of technology too. From a pace perspective, you might have heard this before, and I kind of say this at the intro. The industry is quick, right? There's cycles that are known, there's cycles that are not known, there's customer interactions that you might be familiar with, some surprises, right? So it tends to be very dynamic, right? So we as a company and as a group have to be able to essentially keep up the pace, right? Make sure that we are innovating with it, that we're doing our work in the best way that our customer wants us to. All right, so that's it from a company overview. So I saw a couple hands that were aware of semiconductor packaging, but I'll do a little bit of background here. Essentially, packaging connects the chip functions to the outside world, right? You may have designed the best product, but if you don't have that package to go along with it, you're essentially kind of hindering yourself, right? From a macro perspective, right, the goal of packaging is to control power, performance, and yeah, there has to be an element of cost. It has to be efficient for us to produce it, for the customer to buy it, right? From a micro level, and again, going back to some of the work that is going on here at Purdue, is that basic unit functionality. How does the package interact with the die? How does the material interact within the package? How do we make sure that that package has longevity? How do we make sure that is going to function in the extremes, right, of the ranges that application is going to perform? And again, ultimately, make sure that that connection to the outside world is reliable, is consistent, and it has a long life. Don't know if you guys knew this, right? But for the first package was invented back in 1965. From there, thousands of packages have been developed, right? And some as a progression of others, some as a complete offshoots, right? But now we have greater availability of materials, of knowledge, right? Greater processing powers, tools that enable us to do this, right? So while we have a lot of packaging development, like I mentioned at the beginning, right, this is going to continue to evolve, right? As applications continue to evolve, as our customers, our market, right, continue to ask us to push the envelope. So let me walk you through a couple of what I will call unit level packaging techniques. So the folks that answered earlier that were familiar with packaging, do you know what wire bond is? Yeah, okay. But it's essentially connecting that die using a metal wire to either a lead frame or a substrate, right? To make sure that that interconnection is active and to the board. We have a number of wire bond packages that we support, and a number of wire bonded laminate packages that we support. So the structure looks kind of like this, where you have the die that is attached through some sort of adhesive, right, to a pad on the lead frame, right, and all of it is molded together, right, and you see the wire that is connecting from the die to that lead, right. This is the same or similar view, but on a substrate level, right? So you can quickly see, right, the form factor is different. They tend to be a little thinner and not necessarily occupy a whole lot of space, right? So think about a board when you're trying to connect a package, right? If you can move from one form factor to the other, you just enable that space to be smaller, right? So your device could be smaller. You can fit in different applications. And then you can get fancy with it too, right? So this is a 16 die stack memory. So now we have not only the die connected to the pads, but you can do die to die bonding. You can see here, right, it's also different size die. So the complexity that we're working with, and this is actually a production part. This is not just a drawing, by the way. But the complexity that we're working with is pretty high, right? Then we also have a flip chip package, and so that's an actual part, but this is a cross section of the part where you have the bump die that sits on top of the substrate, and then it's attached with solder balls. So there's no wires connecting the die to the substrate. And again, from a finished product perspective, you can see it on the screen, right? So this is a bare die flip chip BGA with passives on top. So this would be an SIP or a system in package, right? And typically what that entails is multiple functional chips in the same package, right? So again, going back to form factor, you can add a lot of functionality to a device and not necessarily use a whole lot of space. So what you see on the screen is SIP packages and antenna packages. All right. So again, finished parts on the screen, and then the cross section or kind of the inner workings on the middle screen here. Okay. So again, if I were to pick on the flip chip BGA part, so MCM is multi-chip module. It's going to open up and it's going to close. So when this opens up, in your head, kind of think about all of these components are a different process. All of the materials come from a different supplier, and we essentially need all of them together to have the part, right? So we have a ball array that may be, fully populated or not. We have the substrate. We have the passive. Let me see if I can run that again. And of course, we have the multiple dies, and then enclosed with the lid. In this case, a metal lid. Okay. So aside from the unit level packaging, right, we also do wafer level packaging. Or the industry, as a whole, also does wafer level packaging. Now, for these packages, we don't necessarily rely on lead frames or laminates. We rely on RDLs or redistribution layers, right? So smaller form factor. And it enhances the ability to manage heat within the package. And the cross section kind of looks like this. I don't have one with me, but think of a wafer and mold on top. That's probably the easiest visual to have, right? And then you have the fan-in version, the fan-out version. I'm not going to read you the slides here, but it's essentially how is those layers essentially used and distributed across the package. Okay. Now back to packaging itself, right? I mentioned the first package in the '60s. The technologies to enable that packaging happened beforehand, right? So in the 50s, we got wire bonding, and then our packaging has essentially continued to evolve, right? So partly because of the industry, right? But partly because the market almost demands it, right? The way that we're using electronics today is different. Our demand for power, for energy, for data is different, right? So you see our evolution into now be more moving to a stacking version, right? To again be able to move faster as you're controlling your signals, right? And be able to have many functions within the same package work together. So you might have heard about 2.5D and 3D, right? So I have a description of each of the packages here. This is going to do the similar thing as the other one did, and I'll show you the twice, right? But you have again, right, a ball grid array. Yeah, at this point now you also have passives at the bottom. You have passives on top. You can also do that in other packages, by the way. But let's run that one again. But you're adding again more complexity, and some of the parts are coming from different customers, right? So we gotta make sure that we have enough of the materials, enough of that die, right? But also understand what that structure needs to be for us to be able to produce that part. So this is DSM BGA is the dual-sided mole BGA, and the key thing here, right, is that we are enabling those mega trends that we see in the industry as we see them kind of happening, right? Our R&D departments are working up front, right, to make sure that we are driving that advanced packaging innovation and combining, right, the ability to, yes, work on a small scale while controlling power and improving performance. When we look inside of Amkor, right, I mentioned that we support a number of different packages, right, across all the markets. So I'll just leave this here for a little bit. And this is just representation. This is not inclusive, right? But on a communication standpoint, we have the SIP or the antenna packages that we saw. So AIP is antenna in package, AOP is antenna on package, right? So depending on the form factor. On the automotive side, we still do a lot of wire bonded parts, right? We're seeing a chip array BGA, but we also have a lot of the leaf frame parts there, a lot of the power discrete parts. On the consumer, heavily on the flip chip side, but also wafer level. And then you see MEMS and SIP also playing a part. Excuse me. And then last but not least, right, high performance computing. We know about 2.5D, and we know about, right, that being an evolution from flip chip. But then as we go into the future, right, moving into SWIP, S-Connect as an option. So all this is great, but then, how does this all work? How do we fit in the industry, and why do we exist, if you would, right? And how do we support other companies? So, think of a big map, right? And you have your OEMs, right, or end applications, working with the semiconductors company to drive the design process. So those will be your fabless and IDM customers. And then they have to work with the foundries, right? If they don't have wafer services, right, to create that wafer. And then we kind of sit in that middle. Once the wafer is created, then we can essentially play a role. We don't do wafer manufacturing, we do wafer processing and unit level packaging. And then, once it crosses our line, right, then it will go into that final product assembly, right? Inside of, let's see. Maybe I'll go the other way. It's thinking. Start it again. The other way. There we go. So I mentioned kind of the supply chain being a big topic, right? So each step of the process, you have different considerations for your supply, right? For us, it starts with the wafer, right, and all the materials that we'll need. But even before that, you have to account for all the supplies into the wafer fabrication, into the assembly and test house, into that board assembly, and ultimately into that final process, right? So from our standpoint, we're trying to coordinate, right, as it comes into assembly and test portion of the process, right, making sure that we have the right materials and, of course, the right amount at the right time, right, so that we can release that into the line for production. And it's going to make me come here every time. So one of the things that we figure out over time, right, we started with assembly and test, but we also, essentially discovered the need or implemented the ability to do full-scale service, right? So from the design portion with our customers all the way to drop ship. And essentially what that means is the parts are finished. We're going to hold them over here for a period of time before we ship them to either back to our customer or to their customers. But again, inside of this, right, you see materials management. So we do a lot of work there. Our wafer bump and probe dicing, right? So all of that is housed under our wafer level services business unit. That also then goes into our package assembly. So ideally completing what we call bump, probe, assembly, and test, right? SLT stands for system level test. And again, back to drop ship, right? So that we ship it directly to the customer or to their end customer. We're not a make to stock company, we're a make to order, right? So typically our orders are filled, right, or shipped at the same time that we're producing. So we're not necessarily have a warehouse with parts just sitting around. And you see that we have the same offering across all of our products. And actually, let me go back in here and kind of make a comment, right? Because as we support the different packages across the services, right? We're not trying to do a one size fits all, right? We want to make sure that our assembly is fit for that customer, for that package, that our test is fit for that platform, for that configuration that they're looking for, and making sure that we're understanding all those requirements. So I mentioned that we played in all markets, so I'll give you a little preview of what that looks like, right? So about half of our revenue is tied to the communications market, and you know, think of it primarily as a smartphone type market, right? So both ecosystem, the iOS ecosystem, the Android ecosystem. Our second major component is automotive. So I mentioned that we are the largest OSAT, right, in the industry, and about 21% of our revenue is there. So think of things like, you know, like ADAS, advanced driving control, and silicon carbide and power. And then HPC, right, a big topic nowadays. So our revenue there currently is about 16%, and that is growing, right, as that demand is growing for that 2.5D and other solutions for AI. And then last but not least, right, we do also play in the consumer space, and primarily in IoT, right, in the Internet of Things. We're not, you know, the CPU portion is not something that the companies will outsource, right, but the GPUs, the other components are, and again, you know, from a wearable standpoint, everything is here. And then just a couple of visuals here. So if you were to pull out your phone, you know, and this is not something you can necessarily see, right? But when you think of a function, there's a package that goes with it. When you think about, you know, kind of what that form factor looks like on the phone, you know, these are some of the units that are represented there, right? So from the ability, right, to A, have a camera, B, be able to flip it and know the orientation, right? Your controls, right, from a sensor perspective, and again, a lot of different packages contributing to that phone, and essentially we're constantly asking, okay, how do we get faster, better performance out of our phones, right? How do we manage that power? So we do that through packaging and packaging innovation. Same thing goes for cars, right? You know, nowadays there's a lot of push for EVs or electric vehicles, right? And EVs goes with electrification. We need power station, right? We need to make sure that they're charging faster, that they're charging cleaner. You know, everybody is concerned about range, so how do we improve that? How do we make batteries smaller and lighter, right? And how do we essentially enable the new applications through our packages? And then HPC, again, probably getting a lot of press these days, but so all the functions that high performance computing enable, we're supporting through packaging too, right? And how do we essentially enable the fabless companies, right? Those companies that are just doing the design to come in and be able to plug into to our package offerings. And then last but not least is IoT, right? So on the consumer side, how do we kind of bring it all together to essentially drive that experience that we see in, on the service side, we don't see it, right? On the phone, we experience it, but we don't necessarily see it on the consumer product, right? Because we're touching, we're interacting with it more often, right? So how do we bring that experience to the consumer enabled by packaging? All right. So then actually, let me go back one. So I mentioned, right, that we announced last year that we're planning to build a facility in Peoria, Arizona. Currently, we have a headquarters in Tempe, Arizona. Our location there is not necessarily big. We probably have about maybe 400 employees there, growing in the next couple of years once that factory is open to 2,000, 2,500 employees, right? So from an opportunities perspective, right, it may not necessarily be big or extensive at the moment, right? But growing more as we get closer to that. I'm here today as I'm gonna call it as an ambassador, right, for Amkor, but also to Purdue, right, making sure that you are aware of who we are, we're aware of the work that is going here, right? Ideally, that's gonna spark some interest, right, that essentially we'll continue our work together. And once we get to the point that we can start active, right, or be more active on the recruiting front, right, once you come in, we have all the systems in place, right, and we have all the drivers, I guess, internally, right, to make sure that we are not only hiring you, right, but training you, retaining you, and making sure that you're growing through, right? So we have, my opinion, again, very biased, right, but great benefits, great opportunities for growth, and again, the abilities on the front end to bring you into a role that fits what you're looking for. Somebody had asked earlier, or through the conversations, of why Arizona. So when our founders started the company, there was Korea and there was an office in Philadelphia. A decision was made to move to Arizona. And Arizona in general has grown to be, kind of like a silicon desert, if you would, right? With the amount of companies that are there, the amount of exposure that we have. So Amkor right now is in a prime real estate spot, if you would, right? We're the only US headquarter OSAT. We're scalable, right? You saw we're all over Asia, in Europe. We already have a location here. So it's how do we essentially build from that expertise from an ecosystem perspective or a supply chain perspective. TSMC is essentially going to be our neighbor. So how do we essentially continue to enable that partnership as we work together? Intel is also in our backyard. And from a state perspective, again, very biased, but great state to live in, great state to work in, and the economy is growing, right? We're growing both in population and opportunity. So that's all I have for today. So I'm going to switch it over to questions.
Before we move into questions, I would like to remind you that Juan has kindly bought some Amkor branded swag, I guess is the official explanation. So don't forget to come down to the front to grab some before you leave. Just make sure it's not his actual rucksack, right, guys?
Yeah. Not this thing.
So thank you very much, Juan.
Yeah, you're welcome.
than keen to kick us off.
Hi, thank you. I really enjoyed your presentation. I'm wondering, you mentioned that Amkor doesn't keep too much in their warehouses. They supply as demand is needed. So I'm wondering how, as semiconductor need has grown in the last few years, how is Amkor being able to keep up and predict the demand for their customers?
Sorry, what was the end of the conversation? How does Amkor
How
have
have
been
you,
able to
been
predict
able
the
to-
demand?
Yeah, predict and keep
Yeah.
up with the demand.
So we have a standard forecast window that we ask our customers to provide to us, right? So that is, I'm going to call it by customer and kind of line item. We see what they expect is, to build essentially with us over the next X amount of months, right? We also see where the market is going, and then we have knowledge of customer A and customer B are playing in the same market and competing to the same socket, right? If you think kind of conceptually, even in our personal items, right? The farther out you go, the less accurate you are, right? So their 3-6 month forecast may not be necessarily good, right? But we use our data to understand that yes, this customer has this loader behavior. They participate in this market that is expected to grow at X% over the next, this year and next, right? So we can anticipate that. I mentioned before that we do a lot of work on materials management, so we have a lot of purchasing rules to understand how much materials that we keep in stock, so that we can not only support that demand, but any potential upside that we have. Yeah. So there's a lot of work that goes in between our inventory management team, our procurement teams, and with our suppliers.
Sorry. Yes, so you mentioned that during your time in aerospace, you realized that things moved a little slower. Could you elaborate on how your time at Honeywell differs from Amkor in terms of project timelines?
I don't know that it's a fair comparison, right? And given that I'm not here on behalf of Honeywell, I don't know that it's fair for me to kind of talk. Just, I'll say the roles were different. I was a customer quality engineer, working with both the customers and in the line. And again, right, it was for me, it was a different pace. Right, now I get to see a lot of different customers, right? A lot of different breadth of markets and parts, and like we were talking, just taking that example that you were asking before, right? It's very dynamic because Mari, one customer may be going up, one customer may be going down, and the market is flat. How do I reconcile the two, right? How do I know that I need to support one customer versus the other? How do I know that I need to increase my purchasing of one material versus the other? So it's a little bit more, it was more of a personal decision.
Hi, good afternoon, Mr. Gonzalez. Thank you for joining us. I just had a question about your R&D as well as your manufacturing. So in terms of your need for engineers, mainly do you pull engineers from top universities for your R&D focus, and will you need more engineers for your upcoming plant in Arizona? Because I hear the majority of your manufacturing is done overseas. Are you going to need U.S. engineers for that?
So that's a good question that I can answer with one word: yes. So yes, meaning in all sectors, right? So yes, we're going to need more engineers in the U.S., right? As we grow our factory here, figure that very loosely our workforce is going to be half operators, technician. The other half is going to be engineers and other support functions. From an engineering perspective, you're looking at the full gamut, right? So double E's, chemies, materials, mechanical, industrial materials, right? And that is not just on the R&D side or the production side. We can see those disciplines in the work today, right? So our business unit has a variety of representation from an engineering perspective. My team, I manage a team of 4, for example, right? So 2 are material science engineers, 1 industrial engineer, 1 electrical engineer. So yeah, as we grow our our need is going to continue growing, right? And we're going to see engineers being able to participate not only in the R&D side, but also on the production side and the business side as well.
I'll just pick one of the questions off the list, and I'll be right over to you. One of our students asked, what was the benefit of having the customers so close to your facilities? For example, the plants in Korea, the plants in Arizona, and so on.
Sorry, could you repeat that first part?
No
What was
problem.
the benefit
What
of-
is the advantage of being located very close to your customers, like with the plants in Korea and the plants in Arizona?
So it's huge, right? From a relationship perspective, is important, right? You know, you can have conversations, you can have the talks to, again, drive design, drive opportunities. But also when you think about logistics, right? It makes all the sense in the world. As the better located that we are, the better we can support, right? I mean, as a global company, we can essentially ship our parts all over the world, right? But the closer that we are to their supply chain, the easier it is for us to, you know, to essentially enable business with them. But it starts with that relationship, right? Understanding what they want, understanding what their offerings are, making sure that we're doing that analysis, right? How do we essentially work better together, and then essentially enabling that production for them.
It's a follow-up question on the location. But why are like most of your like facilities located in Asia and like Tokyo and Southeast Asia?
So believe it or not, that's where a lot of our customers have their locations as well. And you know, when you look at the CHIPS Act, right, that's part of what they're trying to do is bring that wafer manufacturing back here in the U.S. But there's a lot of wafer manufacturing that happens outside, right? And a lot of customers that have either their facilities or their customers' facilities there. So the ecosystem has grown there since the industry started, really. Like I mentioned, right, we started in Korea. The seed was planted here in the U.S., but our presence in Korea is pretty strong, right? And they are our center of excellence and innovation, right? So as we expand in other areas, we're doing it both for the markets, but also the customers and their ecosystems.
More questions? We have time for a couple more. Oh, let me see. There.
So kind of a follow-up to the first one, what does the turnaround time look like from you getting an order for like to package a certain chip to you manufacturing it, and specifically kind of like how much can be transferred over from your pre-existing designs? Like do you have to completely redo the whole process, or is it pretty universal?
So I would say to that one, I will give it the standard engineering answer, which is it depends. Right, so from a cycle time perspective, it depends on the product, right? So we have target cycle times for each, right? But we also have the ability to do what we call fast track lots, right? So if there's a need to expedite a lot through the line, we can do that. But again, right, it will vary. What I can do on the lead frame side might be different than what I can do on a more advanced product, right? Ideally, right, on a very ideal case, the wafer is coming into our factory and it goes directly into the line for production, right? That, of course, is not necessarily always realistic. So we have a die bank that essentially houses that and essentially wait for that pulled order, right? That production order for the customer, and we are again kind of make to order. So they'll send us a wafer that have 1,000 die. We'll produce 1,000 units and ship them 1,000 units, right? So it kind of depends, from how long it will take and how long we can turn that. It all depends on essentially them. A lot, I would say very few of our customers essentially preload wafers into the factory, so they're essentially sending us as they have orders. Yeah. And actually, the last part of your question, right? We work with each customer, right? Because the design might be just a little bit different or different enough that we might need to make some tweaks, right? Where we can reuse better, right? But not always can we just say, oh yeah, we can use the same material set or the same lead frame, right? There's a lot of applications where we can, but not all. Yeah.
One last question.
Oh my goodness. Okay. So I wanted to ask that on Amkor's ESG report, they're talking about their net zero goal, and e-waste is such a big concern now. So I guess, like, how is Amkor currently progressing towards that goal?
To the goal, what was your first part on?
Their net zero goal.
Yes. I don't know that I unfortunately know how we're progressing, but we do have an initiative to essentially be net zero by 2050, right? We have an initiative to remove PFAS where we can. We also have, essentially making sure that we're partnering with our customers, right? We recently announced a partnership with Infineon, for example, right? Where we are partnering with our, essentially sustainability goals with them as well, right? So think of it as an umbrella directive, corporate-wide, right? That will apply to each of the locations, right? And all the products. But if we can essentially partner with the customers, make that a little bit stronger.
Well, I think that's all, everyone. I mean, feel free to come forward for the swag and also to say thank you very much, Juan.
Thank you for having me.